Expert dart players are tested for their accuracy and are required to throw a dart to strike the center of a designated target on a dartboard. They stand 3.50 meters away from the dartboard. The distance, d millimeters, that a dart lands from the center of the designated target is measured to the nearest millimeter. The distribution for the population of scores D is shown below. It is found that the population mean, mu D, is 100 millimeters, and the population standard deviation was 80 millimeters. A random sample of 100 dart distances is taken from expert dart players who are standing 3.50 meters from the dartboard. Let D bar denote the sample mean dart distance. State the appropriate distribution for D bar. So D bar is going to be a normal. Remember, the mean will always be the same as the calculated mean. And we're taking 100 samples. Standard deviation was 80, so the variance is going to be 80 squared divided by the 100 because we took 100 in the sample. So that is going to be a normal 164, and that means the standard deviation is 8 for the sample of 100. Determine the probability the sample mean will be within 15 millimeters of the population mean. Population mean was 100, so we're going to go 15 down and 15 up. So that is going to be between, doesn't matter if it's less than or equal to, does it? And 115, and just calculate that on the class pad, just a standard normal CDF, 0.9392. So sorry about the skew with copy on this one. It is generally accepted that if a dart player stands closer to the dartboard, then their accuracy will improve. Rajput, a statistician, is provided with a sample of n values for the distance a dart landed from the center of the designated target. For this sample of n distances, it was found that the sample mean was 93 millimeters with a standard deviation of 103 millimeters. Rajput calculated a 95% confidence interval for the population mean and exported this interval as 81 to 105. Determine the value of n. Well, we can see the width of the interval here is 24. So that means E is 12. Remember, E is half of the width of the interval. The standard deviation is 103, and we want a 95%. So Z95 we can get from our calculator, 1.95996. And then there's a formula that I always remember, and it's stored in my E activities if I don't, which is N sigma over E squared. So N is going to be 1.95996 times 103 divided by 12 squared, which gives me 283.01. So we'll say 283. After considering the 95% confidence interval, Rajput concludes that this sample does not provide evidence that the dart players were standing closer than 3.50 meters. With appropriate justification, comment on Rajput's conclusion. So we know that at 3.50 meters, the population mean is 100 millimeters. If standing closer, we would expect mu to be less than 100. But the 95% confidence interval contains 100, even if only just. So not sufficient evidence to suggest that the mean is less than 100. So Rajput's correct. Now we've got Chen, who is an associate of Rajput. He obtained 500 samples, with each sample consisting of 100 dart distances, where each player was standing the same distance from the dartboard. For each sample, Chen constructed a 95% confidence interval and found that 298 of these confidence intervals did not contain the value mu is 100. So that's 298 out of 500. Chen then made two statements. Statement 1. The 500 samples of dart distances are unlikely to have been drawn from the population of dart distances where mu is equal to 100. Let's comment on statement 1. We've got to comment with appropriate reasoning. So, looking at statement 1, what would we say? I would say that he is correct. If the true mean is 100, we'd expect 5% of confidence intervals, which is approximately 25, not 298. So the observed result is unlikely under mu is 100. You should write that down. Let's look at his second statement. These samples could not have been obtained using a standing distance of 3.5 meters from the dartboard. Just going to draw your attention to the important part of that sentence. He's saying could not. His statement 2 is incorrect. And the reason is that the statement is too strong. He's saying no way, Jose. And that's just not true. It's very, very unlikely, but not impossible.